Monsters are very similar to game objects in almost all respects. Access to monsters when building a screen, however, is directly tied to which monster graphic tileset is currently loaded. This allows a user to make many tilesets worth of monsters to inhabit their game, which can be independently loaded screen by screen. To begin working on a new monster, expand the Monster Graphic Banks folder. You will see that you have two monster graphic banks. For this tutorial, we will choose Graphic Bank 0. Click on Monsters to open up the monster editor in the work area. You'll notice this looks almost identical to the game object dialog, except here we have a tileset dropdown. There are 8 monster tilesets in each monster graphic bank. By default, these correlate to the monster tilesets in your graphic assets folder. If you see a black canvas, it is because you haven't created any graphics for the selected monster tileset. If this is the case, use the pixel editor to create monster graphics. To give a tileset a name, you can go to Project Settings, the bank you're currently working in, select the monster tileset you would like to name, change its display name, and press Set. You can also change the BMP it uses, however, we would suggest leaving this alone. You create animation for the monster objects the exact same way you create animations for the game objects. One difference is the palette. As discussed in previous tutorials, the NES has 4 subpalettes. Monster objects use the 3rd and 4th subpalette. What you're looking at here are proxies only. You're only setting whether the monster uses subpalette 3 or subpalette 4. You will see the actual subpalette on the screen in which the monsters appear. The general practice is to create subpalettes for the monsters here by selecting a new palette, naming it, and setting a few colors to aid in monster design. And then make sure that when that monster is loaded on the screen, that subpalette is the one that's loaded. We will look at that part in the next video about setting up screen info. For now, we will simply make sure that our monster uses a new subpalette, and we will not accidentally change the player's subpalette. Since we already looked at how to create a monster and how to set up its animations, we will skip that here. We're going to jump straight into looking at the object details. In the Details tab, you see those checkboxes again. Obviously, for a monster, we are not creating a persistent player. Instead, we are creating a monster. Each of these boxes has a default meaning in the underlying object collision code. When two objects collide, their respective bits are compared, and the resulting script is called accordingly. For non-player objects, and this includes game objects, it is a good idea to set up solid and edge reactions. Solid reaction is what happens when this object collides with a solid tile. You may want projectiles, for instance, to destroy when they hit a solid wall, whereas you might want monsters to reverse their direction. If you leave health at 0, hurting the monster will subtract 1, which will loop around to the value 255, giving the monster effectively 256 hit points. If you want the monster to be destroyed in one hit, set health to 1. The rest of this interface we discussed in the Game Objects video. Move to the Actions tab. This is where we can create interesting AI using modular actions. Generally, when created, a monster will begin on action step 0. With step 0 selected, you can determine what the monster's state will be when it enters the game. First, select its animation type. We discussed how to create animation types in the game object tutorial. Next, you can set its action. The names for these actions are defined in the project settings, and their actual behavior defined in the script settings. Next to action, you will see a timer. This is where you can set the action timer. 0 is a random number. 1 to 15 gradually increase in length for that timer. At the end of this timer, you can determine what happens using the end action dropdown. Choosing loop will perform no action. Choosing advanced will advance to the next action step and launch the behavior that is set there. Repeat will repeat the current action. Go to first will go to the first action. Go to last will go to the last action. Go to previous will go to the previous action. Destroy me will get rid of the object from the game. Restart the game will behave as if setting the reset button. Win game will go to the win game state. Sometimes, instead of using the timer, you want the animation to control the action state. For instance, perhaps you have a monster that charges up before firing. The end of his charging animation would be the desired trigger for the object to invoke the next action. To do this, we would set end action to loop, and instead use end animation to determine the appropriate time to change action states. Don't forget, you can set animation speeds for actions using this slider. Even though 0 is on the fast end of the spectrum, 0 equates to no animation, where 1 is the fastest animation available and 15 is the slowest. Action step flags represent variable bits that can be checked to cause the monster to behave in particular ways depending on the step. What these bits do is wholly dependent on the genre module and the underlying code. For instance, in a platform game, you could make it so the first checkbox makes the monster ignore gravity. Yet in a top-down game with no gravity, you could make the first checkbox make it so a monster is invincible. If, after setting a few of these bits, you change steps, you'll notice that the selection is related to the action step, not the object as a whole. This is a great way to give certain action steps different properties. For instance, a monster who is only vulnerable in a certain state, where his eye is open, or a monster that only ignores gravity when it's in its spawning state. In future basic scripting tutorials, we will demonstrate how to use these bits in code for various effects. In the meantime, they should be set and saved with each module. If you want to change the label of these bits, you can do so in the Project Settings interface. When you have a monster created, you must name it and hit the Save button. You'll see that it appears in your monsters folder. Notice the Save button is still present. Just like with tiles, this means you are now working on a new object. This allows for rapid creation of monsters. Just like with tiles, if you want to edit a previously created monster, click on that monster in the hierarchy. You'll notice the Save button has disappeared, signifying that the changes you are making are affecting the current object. While modifying a current monster, all changes that you make are being recorded, so there's no need to try and save it again. To return to making new monsters, simply click on the Monsters folder. You'll see that the Save button has returned again. In order to actually place monsters on a screen, you need to make a monster group. Here, you can select up to 4 types of monsters to be in a group. They don't have to be in any particular order. If you plan to have random monsters in the game rather than planned, and you want the likelihood of certain monsters to be greater, you can always have multiples of the same type of monster in a group. Once your monster group is set up, give it a name and hit Save. You'll see that it is now a group in the Monster Groups folder. This monster group is now ready to be used in the screen editor, and you're ready to populate your screen with objects.